Hello students! Welcome to today's lesson where we will understand the differences and similarities between equations, expressions, and identities and how to use them effectively. First, we will look at an equation which uses familiar signs like plus, minus, equals, and brackets, discussing how these symbols guide us. We'll understand that expressions represent quantities that can vary, using numbers or variables, but without an equals sign. Expressions are abstract and serve as building blocks for equations. You'll learn to recognize expressions and understand their role in forming meaningful equations. Finally, we'll explore identities. These are special types of equations that hold true for all possible values of their variables. Understanding identities helps us discern consistent and universal truths in algebra. As we move through the lesson, we will see how understanding these terms will help us solve a variety of algebraic problems confidently. Let's delve into the main body of today's lesson on understanding variables, expressions, and identities in algebra. Let's look at the equation 3x plus 4 equals 10. Here we notice the use of the plus and equal signs. These symbols are crucial because they guide us in solving the equation. The plus sign indicates an addition operation, and the equals sign shows that the left side 3x plus 4 is equal to the right side 10. It's important to follow the order of operations known as BIDMAS, brackets, indices, division and multiplication, addition and subtraction to solve equations correctly. But don't worry too much about this for now, as we will explore this further later in the unit. Importantly, an equation always includes an equals sign, which differentiates it from an expression. An expression is a combination of numbers, variables, and operations, but does not include an equals sign. For example, 2x plus 5 is an expression. Expressions can be simplified or evaluated but not solved in the same way as equations because they do not state a relationship of equality. Think of expressions as phrases in the language. They represent quantities that can change, like x in 2x plus 5. Expressions are the building blocks of equations. When we set two expressions equal to each other, we form an equation. Expressions like these allow us to generalize and work with numbers without needing to specify their exact values. An identity is a special type of equation that is true for all values of the variable involved. 0x is identically equal to 0. 2x plus 5x is identically equal to 7x. 3x minus 4 is identically equal to 3x minus 12. These are all examples of identities since they are true for all values of x. Unlike regular equations which are true for specific values of the variables, identities hold universally. Understanding identities helps us recognize patterns and consistent truths in algebra. For instance, 3x minus 4 is identically equal to 3x minus 12 tells us that the two sides of this identity are always equal, no matter the value of x. Throughout this lesson, remember that these algebraic terms are tools that enable us to solve various mathematical problems with confidence. With practice, you'll become proficient in distinguishing and using equations, expressions, and identities in your work. Let's move on to some examples. Consider the expression 5x plus 2. This is just a combination of numbers and variables without an equals sign. We can't solve it for a specific value of x, but we can solve it for given values of x. For instance, if x equals 3, then substituting in this value 5x plus 2 becomes 5 times 3 plus 2. This equals 15 plus 2 or 17. Now let's turn this expression into an equation by setting it equal to something. Let's say we have 5x plus 2 equals 17. We have an equation, and we can solve it to find the value of x. Subtract 2 from both sides to get 5x equals 15, then divide by 5 to find x equals 3. Next, let's look at an identity. Remember, an identity is true for all values of the variable involved. Consider the identity a times 1 is identically equal to a. This is true no matter what value we choose for a. Let's verify this identity with specific values. Suppose a equals to 2. Then the left side of the identity is 2 times 1, which equals 2. This is equal to the right side, which equals 2 also. Both sides are equal, confirming the identity for this particular example. Finally, let's work with an equation to solve for a specific variable. Consider the equation 4y minus 7 equals 9. To solve for y, we first add 7 to both sides to get 4y equals 16. Then we divide by 4 to find y equals 4. By practicing these examples, we can clearly see the differences and similarities between variables, expressions, and identities. Keep working on similar problems to strengthen your understanding of these fundamental concepts in algebra. In today's lesson, we delved into the fundamental concepts of variables, equations, expressions, and identities in algebra. We started by highlighting the importance of symbols in equations, such as the plus and equal signs, and how they guide us in solving equations. We distinguished equations from expressions, noting that expressions, which are combinations of numbers, variables, and operations, do not include an equal sign and cannot be solved in the same way as equations. Next, we examined identities, a special type of equation that holds true for all values of the variables involved. We discussed how identities reveal consistent patterns and truths in algebra, helping us simplify complex problems. These terms are essential tools that enable us to solve various mathematical challenges with confidence. With continued practice, distinguishing and using equations, expressions, and identities will become second nature in no time at all. Watch the rest of the GCSE Maths course at Sophos Education.